This episode is sponsored by Honeybadger. In addition to Honeybadger's great error monitoring service, they also have an uptime monitoring for web developers. And Honeybadger has recently shipped an update that allows for public status pages that can help communicate outages to your customers. In addition to your uptime monitoring, Honeybadger now monitors your SSL certificates. And Honeybadger now has actions which will allow you to do bulk updates to all your errors, or you can set defaults for incoming errors. In this episode, we're going to take an interesting look at using a label printer. So we got a tweet right now, and this label printer will then receive it and it'll print out the text version of that tweet. So as we can see here, we got the tweet and it printed it out. And this will poll every minute to check for new tweets that have tweeted the @DriftandRuby. And this is actually going to be a fun thing where I'm going to leave this printer up and running with this service for a few weeks, so you guys can @DriftandRuby on Twitter and send me a message thanking me for the videos or whatever you want to say. Hopefully it's nice, and it'll print out right here on my desk. And the printer that I'm using for this is a Brother QL810W, and we will be using a gem to interact with this label maker, but we're interacting with it in a different kind of way. So we're going to use a CUPS interface, which essentially, if you have any kind of printer that's connected to your computer, either Wi-Fi, networking, or USB, then you're going to be able to use this methodology as well. It doesn't have to be specifically a label maker. And if you wanted to set this up remotely in a headless system, then you could use a Raspberry Pi that would have this Ruby service running on it, and it would also have the printer drivers installed and connected for the particular printer that you're wanting to use. And from there, you would use the CUPS FFI to get all the printer names. You can then select one of the printers, and then you can print a file, or you can print a binary blob of data. In this case, we're going to be using the text plane. And so to get started, I'm going to bundle add the CUPS FFI. And do keep in mind that this library hasn't been updated since late 2019. However, I did review the source code pretty carefully, and a lot of it is pretty much just going to work. Unless if there is a major revision to the CUPS API, I pretty much would consider this gem stable. Meaning that it hasn't really been abandoned, but there's just no new features or changes that really need to go into it to get this to work properly. And another thing that I like to do when I am interacting with a physical device or anything that I'm really kind of just unsure about is that I'll create a test file. And with this test file, I'll just explore how I'm going to use this device. It could be an API or some other kind of interaction. Just something where I can really just extract all the complexity of my application and just have a single file that I'm having to worry about and debug. And once I get this to a happy point, then I can extract this and place it into my application. So first we'll require the CUPS FFI. And I know that I'm going to want to have some kind of class around here. So I'm going to just have a class called printer. And we'll have a class method called print. And then we'll create a new instance and we'll call print. So with this, we'll then have a print method. And so within here, we can take in some kind of message on a new instance, and then we're going to print out that message. So we can initialize with our message, and then we'll set the instance variable message is equal to message. And then we want something where we can call the printer, and then print data. We'll want to print the message. And again, this is going to be a text plane. So we need to define our printer. And this is where things can get a little bit tricky. So in the documentation, we saw where we can get the printers, and this is going to call the CUPS printer and then get all printer names. And for now, just because we're testing, we can do a puts and then the printer, and then at the bottom here, we can call a printer.new. We won't pass in any kind of message, and we'll call .print. So if we run this code, you'll see that we'll have three different printers. We have the Brother, an HP, and an HP Fax. So this first one is one that we want to use. And keep in mind, just because these printer drivers have been installed on this machine, we got a certain name. This name could be different on the exact same printer if you were to install it on a different machine. this is the name that this computer has set for this particular printer. So with this, we know we got the brother_QL_A10W. So we can create a new instance of our printer with the cups printer.new, and we'll just pass in this string. And because we may be calling this multiple times, I'm going to memorize it with a printer, double pipe equals, and then the cups printer. So now we're ready to test out actually printing something. So we'll print the data for the message, and at the bottom, we'll just create the message, hello world. And so when we go to run this, it's going to execute, and then we'll see it print out. However, there is one little complication with how this is going to print. You'll see that even though we're just printing hello world, it is printing out a whole bunch of little sheets. And if we were to look at these sheets, it says hello and then world. So all of this got chopped off, and that doesn't look really good. And so in this situation, this isn't the fault of the gem or anything really. So I'm going to pull up an IRB session to test things out a bit further. So I will require the cups FFI, and I can call the printer, and we'll just create a new instance of the cups printer. We can inspect this, and we see we got the name and a connection is nil. We can try to get a list of methods to try to dig into here. But ultimately, what I had to do to figure this out was to take the printer name and then call the cups ppd, create a new instance. We'll pass in the printer name and then nil, and then call .options. And this is going to be specific for your printer. Every printer is going to be a little bit different, but we can scroll up and look at all the different choices. So in this particular printer's case, we have a color mode, and this color mode can be grayscale. We then have a cups print quality, which we can choose normal or high. And then we have a cut media, which in this particular case, because it is a label maker, we can cut the media, meaning that it'll tear the sheet of paper. And you have a few different options. We then have a media type, and you can set this for labels, rolls, or anything. And then a page region, and if we look at the default choice for the page region, which it's actually not the page region, but rather the page size that's going to matter here. We have a 12mm by 12mm, and that would explain why our words printed out just a few letters, and then it returned to a new page essentially. And if we look down, the type of roll that I'm using is 62mm wide, but the length of it is going to vary based on what I'm doing. If I have a very short message I want to print out, then printing out 100mm is going to waste a lot of that label. So instead, I want to use the custom option. So I'll create another method called options here. And so one thing I want to set is the cups print quality, and we'll set this to high. We don't need to, but we can also set the media type, and we'll set this to roll. And then we have the page size, which to do the page size, we'll have a custom dot, and then some kind of width times some kind of height. So we'll interpolate in the width, and we'll also interpolate in the height. The width in our case, we know is 62. However, the height is going to be a little bit more complicated. And the reason why this is going to be a bit more complicated is because we are dealing with a very short width, so there's only so many words that we can fit on each line. So our height is going to be dynamically changing depending on how big of a message that we want to add in. So before we can determine the height, we can take in our message, and we need to convert it to some kind of array. I've already done the pre-work for this particular label and the font size it's using, and I want to make an array of the message. So we'll have a text array, and this text array will take in the message, and then we'll do a scan. And essentially what this is going to do is we're going to look at all of the words up to 22 characters. And to be honest, I didn't come up with this regex. I did just do a search on Google, given my criteria that I wanted to split words so that I have a maximum number of characters for each line. So then we'll have the text that we're going to deal with, and there are some things that we have to know about our particular printer. For example, our printer is not going to work with emojis. So if you do have an emoji, then it's just going to basically error out anything at that emoji and later. So your message would be cut short. And I also found, in this particular printer's case, when I am using a custom width, the margins are a bit messed up. So I do have to add in a new carriage feed and also a space. I can then interpolate in the text underscore array that we just created above, and then we can join this with a new carriage feed again. And I'm also going to add a space just because we need that space in order for the margins to work out properly. And this is just in this particular printer's case. And then we can call in code. And on this encode, I just want the ASCII characters. And if there's any invalid characters, then we want to call the replace. Or if there's any undefined characters, then we also want to call replace. And we're just going to replace with an empty string. So now that we have the text that we're actually going to be printing out and the text array, we can come back up to the height and we can take our text array and we can get a dot size on here. And this dot size is basically going to tell us how many lines of text we have for our printout. And then we can multiply it by a magic number. And in this case, I'm choosing 6. And the reason why I'm choosing 6 is because this is the height of the characters in millimeters for each line. So you might have to play around with yours just to get the right number, and I just want to return an integer. So this height gets injected into the height up here. And so now that we have these options, we can just come up into our print data and pass in the options. And we should be able to test this out now. Oh, and one thing I forgot to do is add the millimeters to this page size, which is going to be important. So with this now set up, we can go ahead and run this again, and we should get our printout. It's a bit bigger than before, and here is our test message. So you can see it didn't fit on there all the way, but it is pretty close. And the reason why is because we didn't actually print out our text here. We just still have our message. So what we need to do is come down and we need to get this text where we have the carriage returns and the spaces in order for this to print out properly. So I can just replace that message with the text in the print method. We can try to run this again. We then get our printout, and if we were to look at this now, it looks a lot better. But you can see at the bottom the printer bit did get chopped off, so we might need to add a little bit more height to our magic number. So if we change this to a 7, we can then print it out again, and I did update the print message just so it's on multiple lines, but it printed out. We can then look at the message, and that looks great. So now that we have something that is working, we can then incorporate it into our application. So we can take it out of this test file and move it into its proper and final resting spot. And so in my case, I'm just going to move this test up into the models, and then we'll rename it as printer. We can then come in and delete our test message, and now we have an API to interact with the cups, which will then print to the label maker. And so the application that I want to make is some kind of Twitter feed. So as tweets come in, then I'll get a message printed out on the label maker. And we're not going to use any gems for this. We're just going to have a class Twitter, and we're going to have to call out to the API. So I'm going to have a user underscore ID, and we'll set this equal to some kind of environment variable, user underscore ID. And then we'll have a similar thing for the bearer token, which is simply the Twitter's API authorization token. And so I'll leave it up to you how you want to import in these environment variables. However, I like using the .env-rails, and I would typically add this to the development group, but just for this application, I'll add it in through the bundle add. And this will allow us to have a .env at the root of our application, where we can then put in the environment variables. So this is going to be some kind of number, and this is going to be some kind of token that we get from Twitter. And because this will be defined for my Rails application, because I've added into the general gems, we can have a .env, and we can call the railtie and .load. And this will be in the config application.rb. So for this Twitter class, we'll have a class method, self.fetch, which we'll just create a new instance and call fetch. And I'll first have a guard clause because this is going to allow us to skip everything if we don't have anything coming in. So we can have a return if the tweets, and if there's no tweets listed, then we're just going to skip everything that we're going to do here. So this tweet method, I'll make it an instance variable where we'll double pipe equals just to memorize it. And this is where we'll make our API call. So at the top, we're going to require the net HTTP, which you might have some other kind of HTTP library for your application, and you can use that here just as well. But I like using what's been provided. So we'll set our URI is equal to the URI and then the URL. And this URL is going to be something that we have to define. And I'm going to make these all private methods because we don't need to interact with them outside of this library. And so we're going to need to add some params into this URL. We know that we're going to need the tweet.fields just so we can get the created at. I also want to know who made the tweet, so we can call in expansions is equal to the author underscore ID, and then we can call the https api.twitter.com/2 users. We can interpolate in the user underscore ID that we set at the top. We can then get the mentions with a question mark so we can pass in some params, and I'll just call the params, and we'll join each one of these in the array with an ampersand, and that should be good. So we have our URI. We can then set a request is equal to the net HTTP get. We can create a new instance of this passing in the URI. We can set a header for the authorization, and we want to set this equal to the bearer, and then we can interpolate in the bearer token. We have our response is equal to the net HTTP start, and then we can pass in the URI host name, the URI port. We are going to be using SSL, so we do use SSL, set this equal to true. And then we can call the http.request, and we can pass in the request that we set up before. And so we should get some kind of response. So I'm just going to call the json.parse and the response.body. And for this JSON response, if the key data is nil, then we don't have any tweets that we need to look at. However, if there are some tweets, then we can get the tweets data, and I actually want to go from the oldest to newest, so we'll call a reversal in here. And before we go further, it probably would be helpful to look at this endpoint API that Twitter provides in their playground. So we have the user's ID and the mentions. We pass in a ID. This was just the default one that was provided. And then under the expansions, we have the author ID and the tweet.fields. We have the created at. Both of those we're passing in through the parameters in the Ruby application. So we can run this. And when we run this, it's pretty interesting. We get under the data array, we get a bunch of hashes. We have an ID, text, and then the author ID, which is just another ID. But if we scroll down to the bottom, there's an includes users after the data array where we have the ID and then we can get the names. And so that's going to be very helpful when we are creating our Twitter text. So we can set a user is equal to the tweets. We can dig through the includes and the users. And because this is just an array, we can find, we want to find where that user ID is equal to the tweet, which is part of this tweet's data. And we don't want to find it by the ID, but instead by the author underscore ID. We can get the username with a user name. We can show where this was created at, and we can also display out the text. So if I pull up the Rails console, I can then just call twitter.fetch, and this should return all of the text. And it does. And if we scroll up, we can see where we did the puts outs, and we can see those texts there. So now I want to persist this because if I were to run this in a loop, then the label maker would be printing out the same thing over and over and over, and that would not be a very good experience because it's going to waste a lot of paper. So we need to modify this Twitter class a bit. And first, I'm going to just generate a model for our tweets, and we need to have a few things in here. We need to have the tweet ID. It's going to be an integer, and I'm also going to index this for performance reasons. We can then have a tweeted at, which we'll just make this a date time. We can store the username, the content, which I'll make a text, even though it should never be more than 180 characters or so. And then we're going to have a boolean, and I'm just going to call this printed. And this is going to be important because with this boolean, If we've already printed something, then we don't want to print it again. But if for some reason the printer failed and it did not print it, then we don't want to skip that tweet. We do want to make sure it was printed. So we can go ahead and run railsdb migrate to migrate our database. And now we can call our record, and we'll just set this equal to the tweet.find or create by. And the reason why I'm doing a find or create by is because we might make the API call and get these same records back. Because Twitter doesn't really have a good way to push out through a webhook or something every time a new tweet has been made, this is really what we kind of have to do here. So we have our tweet ID, and we'll just set this with the tweet, and then we'll get the ID key. We can set the tweeted at. We can also set the username. And then of course we want the content. And with this record, if it has already been printed, which in the migrations, I think it would actually be good to come in here and set a default, and we would set this to false. We can then call railsdb rollback and migrate again just to add in that change. So we can add a guard clause next if the record is printed. Otherwise, we can call the printer.new. We could pass in the message and then .print, but the complicated thing here is that I want to update this record if it did print successfully. So I'm going to just pass in the record ID, and then we'll call .print. So in this case, I'm now passing some additional responsibilities over to this printer. And I think if I were to do this, then I would probably make another class called a tweet printer that would inherit from this printer. We can then override or do whatever we want to make it match for the Twitter. But in this case, just to keep things simple, I'm just going to change this appropriately to match our tweet printer. So instead of taking in the message, we're taking in an ID. We then create a method for the tweet, which will memorize this. So we'll have a tweet double pipe equals. We'll have a tweet.find by the ID. And so the message that we're going to create, we want to say that the tweet username set on, and then we can get the tweet.tweeted at. I'm just going to add a colon for a break, and then we can have the tweet.content. We can join all of this with a blank space, and then in the text array, instead of calling the message with the instance variable, since that's not something that's getting passed into this object, we just have our message, which would then be calculated here. And so this printer method, it could start coming in with a bunch of different things. So what I want to do is to add some kind of break on here. So we'll have a job, which we'll set to this printer data. We can then create a loop where we put the job.status, and then we would have a sleep and it would end. And we want to break out of here unless, and then we can pass in some of the job statuses, which we have a pending, processing, and we can check if this is included in the job status. So basically, while it's printing this job, it's just going to loop through and it's not going to do anything else until this is done. So you definitely want to make this into some kind of background worker. So we have a tweet, we can then update, meaning that it has been printed. So we can set the printed to true. And we only want to do this if the job status is completed. So in the Twitter API, we can manually make this twitter.fetch call. It'll gather all the tweets, it'll print them out, and the printer should print these. And so I've launched the Rails console and I ran the twitter.fetch, and I'm getting some great messages from folks. So it's going to print out a bunch of different messages, and it works. This is really pretty cool. So I've gotten a lot of messages, and they just keep coming in. And these are old tweets, so they are coming in from the previous history, but we can see that it all ran and it finished up. So if we were to run this again, it's just going to go through really quickly because it's already printed those. And so as we deploy this application, we would want this to run in the background. We wouldn't necessarily want multiple workers to go out and do this, but we would want this to happen on a recurring job. And this is really going to depend on your environment and just what you have available. I think Sidekick Scheduler or Whenever might be good options just depending on your use case. But I'm just going to add one, and I'm just going to add the Rufus Scheduler. And you do want to be careful with this gem because when you do run it, it is going to run for all instances. So I'll create a new initializer, and I'll just call it cron.rb. We'll require the Rufus/scheduler. We'll set the scheduler equal to a new instance of the Rufus scheduler. And then we can set the scheduler every, and then I'll just do 1 minute. We'll do, and then a Twitter.fetch. And we only want to do this if the environment worker is set. So if I run a binrails console, then it's not going to do anything. The scheduler won't run. But just to make sure, when we are making the fetch, in the Twitter.rb, I'll just make an info log that we are fetching tweets. So in the bin console, this isn't going to do anything. So I'll just start up the Rails application, setting the worker is equal to true. And after a minute, we should see some activity. And we see that it's fetched the tweets. There's one final thing that I want to do, and this is really just a best practice, just so we're not adding an additional load to our server or onto Twitter's. And so I'm going to come down where we're making the API request, and I'm going to add another parameter, and then we'll have a sense ID, just so we're not fetching all the tweets. We just want to fetch since the last tweet that we recorded in our system. So we have a last tweet ID, and we only want to add this if the last tweet ID exists. So we can make this method, and we can memorize it because we are calling it multiple times. And we can do a tweet.order with the tweet ID is descending. We can get the first record, and if the first record exists, then we can get the tweet_ID. And so this way, if we are starting out with a fresh application, the tweet ID wouldn't exist because there are no records, and we just wouldn't add this in. And so for the month of April of 2022, I'm going to leave this up so you can @Drift and Ruby on Twitter, send me a nice message, and it'll print out. And like always, well, that's all for this episode. Thanks for watching. For more videos, check out driftandruby.com.